Welcome to Study Loop.
Let's evaluate the given integral from 0 to 1. So looking at the integrand, we see a fraction. So let's see if we can do partial fraction decomposition. The first thing that I notice is a quadratic in the denominator, so we should see if this thing factors. Always check to factor the denominator before you do partial fractions. This denominator will factor. We can write it as 2x plus 1 and then x plus 1. So this is what the book would call case 1. We have distinct linear factors in the denominator. So the partial fraction decomposition will be of the form a over 2x plus 1 plus b over x plus 1. And then we'll have to go ahead and find what a and b are. And this rightmost expression will be easier to integrate. So here, let's go ahead and looking at this equation over here, circled in red. Let's go ahead and multiply both sides by the denominator on the left-hand side. So by 2x plus 1 and then x plus 1. So let's go ahead and do that and then simplify. So on the left-hand side, we'll have 2. On the right-hand side, we'll have a, x plus 1, plus b, 2x plus 1. And then let's just go ahead and rewrite the right-hand side. It's a polynomial. So let's factor out the x term. And then we have a, and then we have plus 2b. Then for the constant term with no variable, we have a times 1 plus b times 1. So on the left-hand side, we see that there is no x term, or if you want, 0x. So that means the coefficient of x on the right-hand side has to also be 0. So if you want, you could add a 0x to the left-hand side. That will not change anything. And the coefficients of x, must match up. And this is why a plus 2b has to be 0. Similarly, the constant term on the left is 2. The constant term on the right is a plus b. So we have a plus b equals 2. And we have a 2 by 2 system here involving a and b. Let's go ahead and solve this for a and b. Many ways to do this. If we want, we could take this first equation here, solve it for a. So a equals negative 2b. And then go ahead and plug this value in for a and the second equation in green. So we have negative 2b, which replaces a, plus b equals 2. So this gives us b equals negative 2. And then go ahead and solve that for a. A equals negative 2b. So we have negative 2 times negative 2, which is 4. Okay, so we've done the partial fraction decomposition. We found a and b. So that tells us that we can write the integral that's given as the integral from 0 to 1. And then we replace this fraction with the partial fraction decomposition. And then we'll plug in our values for a and b. So a was 4, 2x plus 1. And then b was minus 2. So if you want, minus 2 over x plus 1. And these are integrals you've seen before. For the first integral, if this 2x plus 1 is bothering you, you can go ahead and do a u substitution. Not necessary, but it might help you if you're stuck there. And similarly for the second one, you could also do a u sub. U equals x plus 1. So let me not do the use substitution here, but you can use these to help you if you're feeling stuck. The first integral, we have 4 times natural log 2x plus 1, but then I'll have to divide by 2 because of this 2 that pops up over here. So 4 over 2. And then for the second integral, I have a minus 2, and then natural log x plus 1 in the absolute value from 0 to 1. So we can go ahead and cancel out that 4 over 2 is just 2. And at this point, we can just go ahead and plug in our endpoints and then simplify. Let's plug the 1 first. So plugging 1 in for x, we have ln of 2 plus 1, so that's 2 natural log of 3 minus 2 natural log of 2. And then when I plug in 0, we have 2 natural log of plugging in 0, we have 1 minus 2 natural log of 1. We know natural log of 1 is 0, so both these terms are just 0. And then we just simplify this expression over here in the first parentheses. Here you can write this, you can factor out 2. You have ln 3 minus ln 2. And you could use your log properties to write this as a log of a fraction, 3 over 2. And there's our final answer.